Because the maximum is 3.8, so more than that is past 90. It has to be less than or equal to 3.8. Oh my goodness. B6, have a look. Right. A beam of electrons in a vacuum is accelerated from rest through a potential difference of 4.5 kilovolts. What is the energy? Right, so you have your electrons fired across, and the potential difference here is 4.5 kilovolts. So of course they're going to have a kinetic energy at the end. At the start they have only potential energy, and at the end they have kinetic energy. So for this one we have a formula for the potential energy. The potential energy, it's Q, E and D, where E is the electric field strength, Q is the charge. Now we know the Q, it's an electron. Do we know the D? No. Yeah, so you know the formula for E is V over D. So this will be Q V over D times D, so it's QV. So it's the charge of an electron multiplied by 4,500. Oh, but they wanted in electron volts, so then the answer would be 4,500 electron volts. Yeah.
2D. Oh, yeah.
That was worth 1 mark, by the way.
No wonder.
Okay, can we do part 2? Now this is kind of funny because the kinetic energy here should equal potential energy here. So you already have the answer for part 2. The only problem is it's in electron volts and they want the answer in joules. So a quick conversion. Yeah, I know. So if you convert that back into joules, you get 7.21 times 10 to the minus 16 joules, which is correct. Part 3 is they want the de Broglie wavelength. Yeah, bring it on, de Broglie. So what's the formula, do you remember? H over P. But there's a small problem. We don't know the P is M over V. Now do we know the H? We do. And do we know the M? We do. But do we know the velocity of the electron? No. But we can get it from this answer here. Because, half mv squared. So I have 7.21 equals a half mv squared times 10 to the minus 16. Right. What's the mass of an electron? It's constant number 3. So the velocity of the electron is 39786,156 meters per second. So I can pop that in here to get the answer. Which number is H on the calculator? 6. And mass of electron is 3, isn't it? So the answer is 1.828 times 10 to the minus 11 meters. Now, minus 9 is nano.
Yes.
Minus 12 is pico. Do I want to go pico? Do I? I think I do. 18.3 picometers. Why not? For the fun of it. But in the marking scheme they leave it like this, so what else? Right, next part B. Okay. So what happens now? I think they mean after it leaves the electric field, it then enters, sorry. I'm not clear if in the question they mean after it leaves part A, it then goes into this part B, or if part B still happens in part A. The same beam of electrons is travelling in a horizontal direction and enters an electric field. I'm going to assume that it's left the previous electric field. So it's moving along, and then what happens is this electric field is vertical, so this electric field is going up here. So what happens here is if these electrons are negative, which way will they move when it hits this electric field? And we'll call this part positive and this part negative. So it should want to move down. Not that it's important for the question, so this gets deflected down. Now they give you the electric field strength is 3500 volts per meter, and they want to know what is the vertical deflection of the electron beam when it travels a horizontal distance of 0.15. So they're telling you that this distance here is 0.15 meters, and they want to know what is this distance here. We'll call it H. No, yes. Right, so this one seems a little bit tricky. But you realise it's not too bad if you know what to do first. So what do you think would be the first thing to do? Well, what I'm going to do to try and give you a little hint. Hold on a second. 397861156. Okay. Right, so if you look here, this is what's happening. This is the speed of them, by the way. So these electrons are coming in. Look up, KJ. These electrons are coming in, yes? When they enter this electric field, they get deflected downwards because there's a force acting on it. Which way is the force acting? Well, in this case, the force is active down. Yes? Yes? The question is, what is this distance here? And they give you this distance here.
It will stop.
So the height of
the height.
deflection.
Yeah.
Electrons will stop, but they will stop.
No, they just move downwards. They'll continue on their way here.
Okay.
Do you know what to do?
No.
You do know what to do, because this is exactly the same problem as this. If I gave you this problem, look, and I said a football is kicked out here with some speed, 10 meters per second, and it travels along and hits the water here, and this distance is 20 meters, what's this distance? You would have no problem doing this, would you? No. But if you look, that is exactly the same situation. The only difference is the velocity is very large for the ball, and it's not a gravity force pulling it down. What force is it? The electric force. But it's the same. So what we'll do first...
You don't know the angle.
No, but it's horizontal. So you don't need to know the angle. It's just like this one. It's called an analogy. Yes. Get the idea? So what shall I do first? We have a choice. We can calculate the time first if we want. But I would like to get this force here on, let's say, one electron. So what's the formula for the force? Do you remember it? QE just. In an electric field. So, also from Newton, what's the formula for F? ma. So the acceleration vertically is QE over m. Now, do we know Q? Yes, we do. What's Q?
Constant 3.
The mass of an electron, correct. Do we know M?
Yes.
Yes, that's constant 3. The Q is the electron charge, which is constant 23, and the mass of the electron is constant 3.
What's the E? Okay, we wasn't.
And we got the E. So if I use my numbers here, the A is 6.16 times 10 to the 14 meters per second squared. So this is just a UVATS problem. Let's look at the horizontal and let's look at the vertical.
There is no ultraviolet.
Huh? UVATS. Horizontally, what's the U? 39786 What's the V? Don't know. What's the A? Horizontally? 0. T? Don't know. It's what we want. S? We do know. 0.15. UVATS. What's the U vertically? 0. V? Don't know. A minus 6.16 times 10 to the 14. That was a 14. T? Don't know. S? That is what we want. That's the H. Right, so what we should do is get the T here. What formula gives me the T on the left here?
V, no.
No?
2S, no.
No.
U.
S equals UT plus half AT squared. The A is 0, so the T is S over U. So it's going to be tiny. 39786 So that's 3.77 times 10 to the minus 9 seconds. I can use that now in here. How can I get the S? Same deal. UT plus a half AT squared. But what's the U? 0. So it's a half AT squared. So that would be 6.16 times 10 to the 14 over 2 multiplied by my T squared. And it's small, but it's not as small as you think actually. It's 4.38 millimeters, which is pretty big actually. Millimeters.
Millimeters.
Yeah.
For time.
No. Which is the correct answer. Alright. Okay. Next part? Part 2?
Determine the flux.
So in other words, the question is simply this. How big of a magnet do you need to use to cancel out the electric field? So there's two forces now acting on the electron. There's the downward QE, and now there's an upward force from a magnet, a magnetic field. What's the formula for a force in a magnetic field? Do you remember?
VIL. What's it? Magnetic.
QVB. They want to know what the B is. So we have QVB equals QE. So B equals QE over the voltage. And the Q is the sorry, not the voltage. Velocity. That's velocity, not voltage.
Q cancels out.
Yeah. Oh yeah. So what the heck happened? No, slow down. Slow down, Stephen. Calm down, Stephen. The Q's cancel. So the B is the E over the velocity. Thank you. Now, the E is 3500 And the velocity is... Where was my velocity gone? I had it earlier. 397,86156.
9?
What? 397,86156. So you get, it's going to be pretty small, 87.9 micro Tesla. But do they want the flux density or the flux? Flux density, which is correct. Alright. Last part now, C. Can I scroll down? Narrow beam of positive ions of neon contains a mixture of two isotopes of the gas. These ions have all lost one electron. The beam is traveling at a velocity. When it enters an evacuated chamber, a uniform magnetic field is applied at right angles to the direction of the motion of the ions so that they travel in a circular arc. The ions of neon 20 isotope travel in an arc of radius. Okay, so what's happening here? Your ions come along basically, and they enter this field, and the field causes it to move in a circle. And the radius of the circle is 0.14 meters. I just want to check my battery. Yeah, I'm good. What else did they tell us? They tell us that these isotopes have lost one electron. So if it's lost one electron, what's its charge?
Minus.
Yeah, so these are all positive charges, okay? Also, you know the velocity. The velocity here is 5.5 times 10 to the 5 meters per second. First question is, what is the flux density of the magnetic field? QVB, but there's a little bit more of a complication now. So you have F equals QVB. Now the good news is we know the Q, we know the V. Do we know the B? Well, that's what we want. Do we know the F? No. So we have to work out the F. What formula could I use to get the F?
M omega squared R.
Not this one. Close though. MV squared over R. Because it's moving in a circle. Yeah? If I put these together, I get QVB equals MV squared over R. V cancels V, and I get B equals MV over QR. Right. Are we given the mass though?
Yes, maybe we use 20.
I would be so sad if they made you do that.
I think we have to use 20.
Oh my goodness.
They use 20?
I'm horrified.
They use 20.
They use 20.
Yes.
Don't be happy about this now. Don't be happy.
Maybe.
They can't make it easy.
No, what they do is, they do it like this. It's not accurate. So if you remember, you can make an approximation here. If you have one proton, you can say that its mass is roughly 1 U. And you have a proton and a neutron, for example, its mass is roughly 2 U. Now, we know it's not exactly this because in the nuclear question, there'll be a bit of a difference. And this difference is what causes the binding energy. But because this is not a nuclear problem, you're allowed to approximate here. So what is the mass of neon 20? That would be 20 U. 10 protons and 10 neutrons.
Okay.
Yep. So, yes, we roughly know the mass. Tekken, what was the U? It was 1.67. Yep.
Times 10 power minus.
Okay, so we're getting the accurate mass.
We're getting a rough mass. We're basically saying the mass of neon is roughly the mass of 10 protons and 10 neutrons, but it will be slightly lower than this. Yes. Okay, so I can pop that in there. What was the velocity? 5.5 times 10 to the 5. And the Q is constant 23. And the radius is 0.14. So this comes out at 0.814 Tesla, which is right.
That's correct.
Yes? Why do you sound surprised? Last part, yeah. Right, so now this one's a little bit weird. Yes, it is a bit weird. Right, can I scroll down?
Yes.
So this next part's a little bit weird. What happens here, you have some ions of neon, but you don't know what ion it is. So for example, it could be neon 21, neon 22, whatever. You don't know. So if the number is different, then the mass is different. If the mass is different, then the force is different and the acceleration and the circle will be different. So this time the radius is 0.154. Now you can still use your formula B equals mv over qr. So what's different? Tell me what's the same and what's different. Is B the same or different?
B is different.
No, it's the same magnetic field. It's the same. Is the m the same or different? Different. The velocity, we'll assume it's the same, because it doesn't tell us they're projected at a different speed. The Q, now he's not clear, but the Q is, I'm assuming, the same because we are told that they are missing one electron and we're not told anything else. It's the radius that is different. So we need to recalculate the mass. The mass will equal BQR over V. What's the B? 0.814. What's the Q? Charge of a proton. What's the R? 0.154. And then what's the velocity? It's 5.5 times 10 to the 5. So the mass is now 3.652 times 10 to the minus 26. If I divide this by U, I can know how many nucleons there are. What's the U? It's 1.66 times 10 power minus 27. So this comes out as, if I divide this, oh nice, comes out at exactly 22. So if I have neon 10, no sorry, not neon is 10. No, they tell you that there are 10 protons. The question is, how many neutrons? Yeah, that must mean there are 12 neutrons. And that is correct. Ah yeah, there's no point in starting a math question now. We have one math class tomorrow. We'll try and do it at what time? 12. Now, I might, listen, so you know, I might run the class a little bit over, like I might go from 12 to like 105 or 110 or whatever, just so I can try and finish the maths paper tomorrow. I would like to have is that our first or second maths paper?
Second.
Good, okay. So I want to have the second maths paper finished tomorrow. Please bring your maths paper I gave you tomorrow. Thank you.